After you've created tables and enforced foreign key constraints, referential integrity between those tables, your next step is to create some indexes for these tables. Indexes are tremendously useful, can be tremendously useful in data retrieval. And remember that a SQL Server index is a B tree and it's automatically maintained by the SQL Server. When you create a table and you declare the primary key, an index is created for those primary keys, for each primary key for each table. But the foreign keys that you've created when you establish the referential integrity, when you declared the foreign key constraints, those columns are not automatically indexed. And because you're going to be joining tables together based on those foreign key columns, you need to have those columns indexed. So let's go ahead and use CIAC. And let's look at the first index we're going to create. It's going to be for the cookie table. Well, here's the little bit of code that if it exists, go ahead and drop it so that I can recreate it. I am going to create a clustered index, and I have to give it a name. And again, the naming convention within each table, the constraint has to have a unique name. So get a naming convention that's going to work for you. And it's create the clustered index on the cookie table and on the column cookie type. A clustered index determines how data is stored on disk. Data is actually ordered by the cluster key, and in this case the cluster key is cookie type. I can cluster either by a primary key, which I would at the time of creating the primary key declare it as clustered, or I can declare clustering by a column that's going to be more relevant for searches and retrievals. And in the way I'm thinking right now, cookie type is going to be more relevant for searches and retrievals than cookie ID. The other parameters here that may not be familiar are fill factor and pad index. Fill factor applies to the bottom layer or the leaf node. Remember I said that indexes are B trees, and at the bottom layer or the leaf node, this is where the data is stored. So the value of fill factor, it's a percentage that you're going to fill each page. So an 80% fill factor populates each data page with roughly 80% data and 20% free space. That 20% free space can be used for inserts and updates that are not in place, and this prevents page splits. This gets into B tree file management. The pad index is simply apply the fill factor to all of the layers, including the root node and every intermediate layer on the B tree. That's the same as the leaf level. So I just can go ahead and say, all right, let's run this and execute this bit of code. Oops, all of a sudden I have my index created. I'm going to just go right on down through very quickly my entire script and run it. And now my indexes are created. And again, if you have this in script form, rather than use the Management Studio GUI, you now have documented what's in place in your SQL Server. And that's it for now.